and negative 3. Which is, again, why do I do this? Because the only reason why I do this is because I have an x squared. And again, once I move it over, now I need to combine like term, which is my like term is negative 18x and negative 7x. That will give me a negative 25. 81 plus 3 to give me 84 equal to 0. Which is, again, this is what we have here. This is what we have in terms that because of the x squared. Just because of x squared, ladies and gentlemen, just because of the x squared, we have to set it equal to 0. Why? Because now, because of the x squared, do you agree that we go back to chapter 6? We need to factor this out. And to factor this thing out, which is, again, do you agree that we need to break the x out? And now we ask ourselves 20, no, not 21. The answer is 21. But again, 84, is there two numbers multiplied to give you 84, but add together to give you 25? Which is, again, I slip and I say 21, which is, hopefully you guys see that 21 times 4. 21 times 4 is 84. And 21 plus 4 is 25, which is, again, this is what we need to do, which is after this, we have to say x minus 21 equal to 0, x minus 4 equal to 0. And then how do I solve for x, which is x is equal to 21 and x is equal to 4. But ladies and gentlemen, for this particular problem, this is what you guys need, is you guys need to check your answer. If you type this 2 answer on MyMathLab, they will tell you it's wrong. Why? Because if you put in 21, again, this is all I did was wherever my x, which is my x, my original problem is here. This is my original problem. Wherever my x is, I plug in 21. Wherever my x, I plug in 21. So again, that's it. Whichever the x is here. This x and this x, I just plug in 21. So again, this is what I have if I simplify them, which is, again, do you agree that 7 times 21 is 147? 147 minus 3 to give me square root of 12, not 12, square root of 44, which is square root of 44 is 12, which is 12 equal to 12, which is, that is your right answer, right? 12 is equal to 12. If you plug in 4 into your x, which is, again, once again, my x is this item right here. I plug in 4 here, and I plug in 4 here, which is, again, if you plug in 4, this is what you have, which is, again, 7 times 4 is 28. 28 minus 3 will give me 25. Square root of 25 is equal to 5, but as you can see on this side, 4 minus 9 will give me negative 5, which is 5 is not equal to negative 5. Because 5 is not equal to negative 5, we cannot use the 4 as your answer. Because you plug in 4 and the two sides are not equal each other. And if they are not equal each other, they are not your solution. In order to be a solution, it has to be something like this, which is, again, it has to be 12 equal to 12. They are equal to each other, which is, in this case, I see that my answer for this particular problem, my answer is 21. That's the only answer you type in your MyMathLab. Okay, so again, this is the one thing is yes, if you look at this thing here, you say, wow, it's a lot of steps. And again, it's a lot of redundant stuff, right? Nothing new, right? Nothing new, you know. The only thing new is you take a square on both sides, right? Once you take a square on both sides, it's just bring back to chapter 5. You have to FOIL them out. Bring you back to chapter 6. You have to factor them out. And bring you to chapter 2. You have to check them, okay? So again, yes, it's a lot of stuff. It's a lot of procedure. It's a whole page on your notebook that you write it out, you know. But again, hopefully you guys see that it's not very, very complex, okay? Let's take a look at another one, and then I'll take what question that you might have. But let's take a look at this thing here, which is same idea, same concept, right? The only thing different now is I put a square root on the right and not on the left like A, right? So again, instead of put a square root on the left, I put a square root on the right. But the first thing, as you can see, your square root is by itself. And if your square root is not by itself, whatever the item is, you just subtract or add to the other side. Okay, so if your square root by itself, do you agree that all I need to do is I take a square on one side and I take a square on the other side? Because a square and the square root cancel each other out. So once we have this thing here, which is x plus 3 times x plus 3, that's your x plus 3 square, and the square and square root cancel out, which is you have 5x plus 21. You FOIL them out. If not, remember, you take the first term square, you take the last term square, you put the two terms together, which is, again, regardless of how you do it, you either FOIL them out or use the special rule. This is what you should have, which is x squared plus 6x plus 9 equal to 5x plus 21. And again, same as before, once you FOIL them out, once you distributive them out, you can see that there's an x squared. And if there's an x squared, in order for us to solve, go back to chapter 6, in order for us to solve, we need to set it equal to 0. And if I set it equal to 0, all I need to do is I move the 5x over by subtract, and I move the 21 over by subtract, right? Again, this is all I did was I take the 5 on the other side, I move to this side. I take the 21 on the other side, I move to this side. And to move it, I have to change the sign. And again, combine like term, if I combine like term, 6x minus 5x to give you 1x, 9 minus 21 to give you a negative 12. And again, once you have this thing here, we still have an x squared, which is if you have an x squared, you have to solve it by factoring. That's the only way we know how to do so far. Until the end of today, you will learn a new method, okay? But again, as long as you have x squared, for now, we have to factor them out, which is there two numbers multiply to give you 12, but subtract to give you 1, which is 4 times negative 3, right? 4 times negative 3 is negative 12, 4 minus 3 to give you 1. And we have to solve this item, which is x plus 4 equal to 0, x minus 3 equal to 0. That's give you x equal to negative 4 and x equal to 3. And again, we cannot, particularly for this square root problem, you have to check your answer. If you check your answer, looking at this thing here, everybody see right here. And again, look at this item right here. All I did was I plugged in negative 4 in. Wherever my x is at, I plug in negative 4. But if you take a look at this thing here, if you recognize this, ladies and gentlemen, if you recognize this item right here, remember I told you guys that can you take a square root of something and it's equal to a negative number? Well, if you look at this thing here, we can see that we can cross out negative 4. Why we can cross out negative 4? Because there's no way you can take a square root of anything and it's give you a negative number. Okay, but again, looking at this thing here, everybody see that we have a negative. I make a mistake, guys. It's supposed to be 20. 5 times negative 4 is negative 20, not negative 25. And negative 20 plus 21 will give you 1. And a square root of 1 is not equal to negative 1. Either way, we do not use this because, again, there's no way you can take a square root of something and give you a negative 1. Either way, this answer is not the correct answer. We just throw away that item away. And again, if you plug in 3 in, which is 3 plus 3 is 6, 5 times 3 is 15, which is, again, 15 plus 21 will give you square root of 36, which is, do you agree that square root of 36 is equal to 6? Which is 6 is equal to 6. Therefore, this is the only answer you have, which is x equal to 3. That's the only number that will work out. Negative 4 will not work out. Okay, so again, this is the only thing that we do in here is we have to check. The other time I did not check because I know my answer is correct. This one here, 2 answer, you have to check both of them. Beside a small typo beside this, again, this thing's supposed to be 20, not 25, and this is supposed to be positive 1, which is again positive 1 is not equal to negative 1. Anyway, before I go to the next slides, question here. Question on the step or question on the procedure of why do we have to check your answer. All right. If you don't have question, let's continue. Let's try another one, right? Let me, well, no. This one is not the same, but again, if you have a cube root, I just want to give you this problem here. If you have a cube root, life is not difficult. Why? Because if you have a cube root, how do we get rid of the cube root? Well, to get rid of the cube root, all we need to do is raise it to the third power, because the cube and the cube root, they will cancel each other out. So again, if you have this thing here, which is again, all I did was I raise it to the third power on the left and raise it to the third power on the right, which is I have 2x minus 5 equal to 3 times 3 times 3 is 27, which is now what do I do? I need to add 5 to the other side to give me 32. So 2x equal to 32. And now how do I solve for x, which is again, this is, even though it's a cube root, it's basically the same as a square root before. And again, C problem is probably easy because they don't have another term, right? You will not have a cube root